Hello viewers, I am Kausalya. Today we are going to solve problems 9 and 10 in exercise 9.1. The problem is the angle of elevation of the top of a building from the foot of a tower is 30 degree and the angle of elevation of the top of the tower from the foot of the building is 60 degrees. If the tower is 50-meter high, find the height of the building. So here, what are all the things we are having? Here we are having a building and here we are having a tower. Right. And you see the tower is 50-meter height. Okay, it is high. So the next thing is, you see the angle of elevation of the top of the building from the foot of the tower. Okay, first let us draw a tower, right? Let the tower be here and this is your building, right? So okay, we don't know the height, right? So let it be like this. Now the tower is 50-meter high. So this is 50-meter high, right? And the angle of elevation of the top of the building. Okay, this is your top of the building. Okay, this is your building. So the angle of elevation of the top of the building from the foot of the tower. So this is your tower, right? This is your tower and this is your foot of the tower. From the foot of the tower, the angle of elevation of the top of the building, right? So it is 30 degrees, right? So here you see, right? So here the angle is 30 degrees, right? Now the angle of elevation of the top of the tower from the foot of the building, right? So let this be your building, right? And you see the angle of elevation of the top of the tower. Okay, so this is your angle of elevation of the top of the tower from the foot of the building. So here what it is 60 degree. So here the angle of elevation is 60 degree, right? So why there is a difference? Here it is 30 degree, here it is 60 degree. Why the angle of elevation gets increased? Because you see, this indirectly says that the height of the tower is greater than the height of the building. That's the reason why here we are having the angle of elevation as 60 degrees. Can you understand? Because you see from the foot of the tower to the top of the building, the angle of elevation is only 30. But from the foot of the building to the top of the tower, it is 60 degree. This indirectly means that the tower is higher than the building. Okay, so your original diagram should be like this, right? So now what is the thing? We have to find the height of the building, right? We have to find this length. So you see this is your diagram, right? So here in this case you have to find the length AB, right? So first we are considering the triangle BCD, right? We are considering this triangle because we already know the value of one side, right? So here in this case we are going to select tan because you see for this triangle and this triangle, this side BD is common, right? So once you find the value of BD, then it will be easy for us to find the value of AB, right? So here, and this BD is the adjacent side for this 60 degree, right? As well as for this 30 degree also. But now we are going to consider only the triangle BCD, right? So it is tan 60 degree. So tan 60 degree is nothing but opposite side by adjacent side. So here the opposite side is CD and the adjacent side is BD, right? So tan 60 degree is equal to CD by BD. So what is the value of tan 60? It is root 3 and the value of CD is, it is 50. So what about the value of BD? BD is nothing but just you have to cross multiply, right? So BD is nothing but 50 divided by root 3, right? So now we have calculated the value of BD, right? Now the next thing is we are going to consider the triangle ABD, right? We are going to consider this part, right? So just draw the triangle separately so that it will be easy for you to solve, right? So here in this case you need AB, right? So AB is nothing but this is your opposite side, right? But just now we have calculated the value of BD here, right? So what is the ratio that relates your opposite side and adjacent side? It is nothing but tan, right? So tan 30 degree is equal to opposite by adjacent. So here it is AB by BD, right? So tan 30 is 1 by root 3. And we know the value of BD, so just substitute it here, 50 by root 3, right? Then the next thing is just cross multiplication, right? So root 3 into AB is equal to 1 into 50 by root 3, right? So here we need to find AB. So just move this root 3 to the right hand side. So here it occupies the denominator part because here it is in the numerator side, right? So here it comes in the denominator. So 50 by root 3 into root 3 is nothing but 3. So 50 by root 3 meter. Okay, this is the value of AB. If you want to simplify further, you see, just you can divide like this, right? 50 divided by 3. So 1 3 is 3, right? So 5 minus 3 is 2 and you are going to bring down this 0. So 20. So 6 3s are, it's 18 and the remainder is 2. So here you can write it in the form of mixed fractions, that is 16 into 2 by 3 meter. Okay. So height of the building AB is 16 2 by 3 meters. It is mandatory to mention the unit here. Right. So this problem gets over here. We will proceed with the next one. So problem 10 is two poles of equal heights are standing opposite each other on either side of the road. Yeah. So here two poles, they are of equal height, right? They are standing opposite to each other on either side of the road. Okay. In between we are having a road. So which is a 80 meter wide. So here this is your road, right? This is one pole and this is another pole. So in between there is a road which is 80 meter wide. Now from a point between them on the road, the angles of elevation of the top of the poles are 60 degree and 30 degree respectively. So find the height of the poles and distances of the point from the poles. So here the thing is, you see, that is a point between the road. Okay, we are having some point over here. Okay, let this be here. You see here the angles of elevation they are not the same. Okay, one is 60 and one is 30. So never place the point at the midpoint, at the center. Okay, either place on this side or place over here, not at the middle. So you see the angle of elevation of the top of the poles, right? So angle of from this point, we are looking at the top of both the poles, right? I am looking at this pole as well as at this pole also. So what are all the angles? One is 60 and another one is 30. So from this diagram, right? Can you tell me which one will be 30 and which one will be 60? Okay, you see here this point is 30 degrees, right? Because from this pole, it is at some particular distance, right? But when you look at this pole, this point lies a little bit near to this pole, right? So here the angle of elevation will be 60 degrees because whenever you stand close to an object, you have to lift your head comparatively higher to view the top of the pole or top of the building. Okay, that's the logic behind this. So find the height of the poles, right? We have to find the height of the poles and the distances of the point from the poles, and also you have to find at what point, okay, at what distance this point is located, right? That's the thing. So you see here I had drawn the same diagram, right? So the thing is, now I am considering, okay, just write down the values, that is mention the names A, B, C, D, E, right? And there is a point and here it is 30 and 60, and you see I am taking the distance, okay, this midpoint, sorry, not midpoint, this point be C, and let the distance CD be X. So then what about the distance BC? It will be 80 minus X because the total distance is 80 here, right? If it is X, then it will be 80 minus X. Right, the same thing I had already explained the previous problem also. You see, if the total length is some 10, right? If this distance is 2, then what about this? 10 minus 2, right? The same thing here. Now, you see, let the length, okay, let the length of the poles AB and ED be equal to H, right? This is just for our convenience. Rather than writing AB, ED, we can mention it as H. and they have clearly given that two poles are of same height, right? Therefore AB is equal to ED, which is equal to H, right? Now the thing is, we are considering the triangle ABC, right? First we are considering this triangle. So here I am taking tan because I need to find this opposite side, and already I know the value of adjacent side. So here we are considering tan. So tan 60 degree is equal to AB by BC. So AB by BC here. Just substitute the values. Tan 60 is root 3 and AB is nothing but H and BC is 80 minus X. Right. Name it as equation 1. Right. Again, now consider the next triangle. Okay. Consider this triangle ECD. Again, here we are going to making use of tan 30 because I know adjacent side. I have to find the opposite side. So tan 30 degree is equal to ED. Okay, this ED by CD. So tan 30 is 1 by root 3, and what is ED? We have declared it as H. Right, so H divided by this CD is X. So again, just do a simple cross multiplication. Here it is root 3 into H is equal to 1 into X. Right. So name this as equation number 2. Right. So here the thing is, you see, both these expressions are in the form of H and X. You see, here also I am having H, here also X, and here also H, and here also X. Right. Now we are going to substitute one term in the form of other. So before that, you see, here the thing is, just I am going to multiply this equation 1 by root 3. Why? Because here I am having root 3h, right? If there is root 3h, then I can easily replace it by x, right? So I am multiplying both the sides of equation 1 by root 3. So root 3 into root 3 is equal to root 3h by 80 minus x. So root 3 into root 3 becomes 3, right? Here which is equal to root 3h by 80 minus x. So just do a cross multiplication. So in the place of root 3h, we can replace it by x, right? So replace it by x here. Just the next thing is, we are going to do a cross multiplication. So when you cross multiply, you see 3 into 80 minus x is equal to x. So 3 into 80, 240 minus 3 into x minus 3x is equal to x. So 240 is equal to, when you move this minus 3x to the right hand side, it becomes plus 3x. So 240 is equal to 4x, and therefore x is equal to 240 by 4 is nothing but 60. Right. So here we have calculated the value of x. Right. So then we can, with the help of x, okay, once you know the value of x, you can easily find the value of h. Right. You see, root 3h is equal to x. Now I know the value of x. So I can find the h. Right. So again, consider this equation. So root 3h is equal to x. Right. Therefore, h is equal to x by root 3. What is the value of x? It is 60. So 60 by root 3. Right. So here in a simple form, you see, we can solve by this also. Okay. Don't go by this way. I'll tell you another thing. Whenever you are having root 3 in the denominator, you see, just multiply and divided by root 3. It will make your process bit easier. Right. So here becomes, what is the answer? Here it will be 60 root 3 divided by root 3 into root 3 becomes 3. So this 3 and this 60 get cancelled. So here the answer is 20 root 3. Right. Therefore, here the value of h is, it is 20 root 3. Right. So finally, you can write as the height of the pole is 20 root 3 meters. And what is the next thing we have to find? So the next thing to be calculated is the distances of the point from the pole. So here the value of x, okay, here it is 60 meter. Then what about the value here? 80 minus x. So 80 minus 60 is equal to 20 meters. Right. So while writing the answer, you have to write it as the distance of the point from this left pole, okay, from this left pole is, it is 20 meter, and the distance of the point from the right pole ED is equal to 60 meter, and the height of the poles are 20 root 3 meters, right? Because since there is an insufficiency of space, I have just filled like this, right? So that's all. Height is 20 root 3 meter, and the distance is just now I have explained, right? So that's all for this video. If you have any doubt, let me know in the comment section. Thank you.